Author, Unified Field Mechanics Research. Published, June 30, 2026. Abstract. This paper outlines a unified systemic model of physical manifestation, integrating localized continuous wave mechanics with Planck-Scale time discretization, by modeling macroscopic matter as spectrally dense harmonic interference patterns, standing waves, and positing a stroboscopic oscillation between localized state vectors and the zero-point vacuum. We resolve fundamental questions regarding thermodynamic efficiency, entropy accumulation, and kinematic resistance. 1. The dominant carrier eigenfrequency of localized matter anchor. In signal processing and waveform mathematics, complex data is transported via a fundamental, unmodulated carrier wave. We propose that this mechanics scales to macroscopic physical systems, e.g., biological organisms or complex lattices. Rather than viewing a localized object strictly through a particle kinematics lens, it must be modeled as a highly complex, spectrally dense harmonic waveform, a macroscopic soliton or standing wave propagating through the quantum field. The carrier eigenmode. All harmonic complexities within the system must phase lock to a fundamental resonant frequency. For any localized physical structure, the carrier wave is its fundamental resonant eigenmode. It provides the baseline harmonic frequency, establishing the structural center of gravity for the system's phase space geometry. Information theoretic determinants. This carrier frequency is not random. It is the mathematical translation of the system's localized information topology, the blueprint. It is determined by the specific ratio of spatial density, fluid dynamics, and molecular structure required to maintain structural coherence, homeostasis against environmental decoherence. Mathematically, it is the lowest energy state required to sustain the specific interference pattern of that localized system. 2. Discretized temporal mechanics. The universal oscillation anchor. Current quantum mechanics grapples with the continuous versus discrete nature of space-time. This framework posits that temporal evolution is phenomenologically discretized at the Planck scale, creating a stroboscopic oscillation between two states. The zero-point vacuum. Neutrality. A state of absolute equilibrium where all wave functions resolve into perfect phase cancellation. It is the unmanifest, infinite potential energy state. The zero-point energy. ZPE. Ground state. The localized projection. Reality. The state of non-zero kinetic energy, characterized by the projection of polarized interference patterns into observable coordinates. This state collapse and reversion occurs at the limit of observable time, the Planck time. The frequency of this universal oscillation is the Planck frequency. Thus, the observable universe operates as a stroboscopic sequence of discrete, localized projections emerging from and returning to the zero-point vacuum. 3. Kinematic and thermodynamic efficiency of stroboscopic architecture's anchor. Human engineering biases equate solidity with stability, assuming continuous matter is the most efficient structural paradigm. However, from a thermodynamic perspective, continuous solidity requires massive localized resistance to entropy. The Planck-Scale oscillation model provides a profoundly more efficient systemic architecture. 3.1 The 50% null state. Adiabatic rest. Anchor. If a physical object were a continuous, solid-state system, maintaining its structural boundaries against environmental friction would require continuous energy expenditure, perpetually generating entropy. By oscillating into the zero-point vacuum, the system spends half of its temporal existence in a state of absolute zero impedance. State 1. Kinetic energy is exerted to project the standing wave. State 0. The waveform collapses into the unconditioned vacuum potential. Zero work is performed. This establishes a 50% duty cycle of existence, creating an ultimate energetic breathing cycle that vastly reduces the continuous thermodynamic load required to sustain complex matter. 3.2 Phase space translation versus kinematic drag. Cybernetic adaptation anchor. In classical mechanics, moving a continuous object requires applying a force vector to overcome inertia and friction, generating thermal waste. In a stroboscopic universe, the object collapses into the zero-point vacuum at the Planck interval. Its systemic geometry, instruction set, can be updated while in this unmanifest state. When the wave function collapses back into the observable state it materializes at its new spatial coordinates. The kinematic implication. The object bypasses the physical friction of continuous spatial movement. It does not drag across space-time. The projection is simply refreshed at new coordinates via discrete phase space translation, allowing the universe to continuously and effortlessly self-correct its geometry toward equilibrium. 3.3 Entropic reset and the eradication of structural fatigue. Anchor. The second law of thermodynamics dictates that closed systems degrade over time. However, fundamental particles, like protons, do not exhibit structural fatigue or aging. Under the stroboscopic model, this is because the localized object is uncreated and fully reinstantiated from the minimum entropy ground state every seconds. It does not carry the cumulative structural fatigue of the previous cycle. It is a flawless, perfect rendering of the current geometric instruction set, perpetually immune to the mechanical wear and tear that degrades classical solid-state systems. 4. Implications for programmable matter. Resonant synthesis. Anchor. If reality is an interference pattern blinking in and out of the vacuum state, then macroscopic matter is never fundamentally fixed. The synthesis of complex matter, e.g., advanced molecular assembly or programmable matter, does not require the brute force kinematic rearrangement of existing atoms. Instead, it requires the introduction of a new localized carrier frequency, geometric data during the vacuum phase of the oscillation. By modulating the quantum and gauge field instruction sets at the exact resonant eigenmode of the desired structure, the unconditioned vacuum energy is forced to collapse into the new geometric pattern upon the next projection. This transitions material science from subtractive additive particle mechanics to direct waveform phase modulation.